Institute Ivrea, Italy, artist in residence at the International Academy of Media Arts and Sciences, Japan, and has also worked in the USA, UK, and Malaysia. As well as directing the work of Haque Design plus Research, he was until 2005 a teacher in the Interactive Architecture Workshop at the Bartlett School of Architecture, London. He received the 2008 Design of the Year Award for Interactive Pieces from the Design Museum UK, and 2009 World Technology Award in Art, a Wellcome Trust SciArt Award, a grant from Daniel Langlois Foundation for Art, Science, and Technology, the Swiss Creation Prize, the Bellewaerde Bulwark International, and the Japan Media Arts Festival Excellence Prize, and the Asia Digital Art Award Grand Prize. His work has been exhibited widely throughout the world, including the Institute for Contemporary Arts in London, Ars Electronica, Transmediale, Hillside Gallery in Tokyo, the National Maritime Museum in Greenwich, Tokyo Metropolitan Museum of Photography, Itaú Cultural in Sao Paulo, NTT Intercom, many, many more. If you'd like to read more, of course, check out his website. So I'd like everyone here to give a warm Kai welcome to Usman Haque.
Hey everybody, thank you for coming. Thank you for the lovely introduction, Scott, and for having me here. I'm going to be talking about my work of basically the last 12 years, and I'm going to go over a number of different projects. I'm actually trained as an architect. My background is in architecture, and I still actually consider that I am an architect, that I'm contributing to the debate around what it means to create architecture. Is it possible to take the lights down a little bit here? It's kind of glaring in my eyes. It also means that I'll be able to see you guys a little bit better and hopefully have some rapport. Please feel free at any point to stick up a hand and ask a question, or even not even stick up a hand. I'd like to sort of develop some kind of rapport if possible. As I said, I'm trained as an architect, and what particularly interests me in architecture is what I call the kind of the software of space. We've traditionally thought of architecture as being the hard, immutable, static stuff, right? It's the walls and the floors, it's the ceiling, it's all this kind of physical fabric. That's the traditional view of what architecture is. But I'm more interested in what happens in between, the sounds, the smells, the temperature, the light, the social relationships, even the electromagnetic fields, all of these things that go together also to make up our experience of space. I'm not saying that this is what architecture is and the physical stuff is not. It's just that this is what particularly interests me. So I'm going to describe my projects in the context of basically these three categories that I've got up here: architecture, interaction, systems. These are words, of course, that mean everything and nothing. They can be applied in all sorts of different contexts, and in different contexts they can be used to justify almost any evil you want. But I have very specific ways of using the words, and so I thought I would start first by describing this. So architecture. As I said, I'm interested in this kind of software of space, the program of space, if you like. What it is that actually helps us experience both the space around us, but also the other people in the space. And this slide, for me, sums it up quite nicely. It's the same piglets on the left-hand side and on the right-hand side, but on the right-hand side, the temperature has been increased by a few degrees. And so by this very small change in the software of space, the experience has completely changed for the piglets inside. They move apart. In a sense, they are kind of adjusting in a very different way to their space. And this is not that dissimilar from the way that walls and doors lead us to experience space. So this is really the kind of thing that I'm most interested in when I'm looking into architecture. The next category is interaction. And I did confess to Scott earlier that I was a little bit wary of espousing my take on interaction to a room full of professionals whose business is interaction. But he said I should just go with it and duck if necessary. So, interaction. What do I mean by interaction? I'm actually going to call on possibly an uncomfortable analogy, But I'd like to describe what it is that I mean by interaction, because I think it's not just about stuff that responds to us. And I'm going to build up the analogy by looking at, in a very broad sense, the history of the philosophy of science. In the 19th century, the universe was so kind of comfortable, right? It was at a moment at which it seemed that if we knew all the starting conditions, we could predict the outcome. All that was necessary was to know to the fullest extent the starting point. And as long as you could figure out what that f of x was, you could figure out what the outcome would be. So the challenge was A, to develop to figure out the starting conditions, and B, to figure out what f of x was in a very general sense. 20th century introduced to us concepts like relativity and uncertainty, and it turned out that we couldn't, even knowing the starting conditions, we couldn't predict with certainty what the outcome would be. Here I'm talking about perhaps at the level of particles, particle physics. And again, like I said, I'm stretching an analogy here, but go with me for a moment. The point was that the 20th century introduced us to this idea that unlike the billiard ball model that we had of the universe in the previous century, that all of a sudden you couldn't say with any certainty what was going to occur. You could only say that there's a probability that this might occur, or this might occur, or this might occur. And it was actually shown that it was impossible even to be certain about some things. And this you might have heard of the uncertainty principle. This was a kind of interesting change of schemes, because what it introduced us to was the notion that the observation is a part of the measurement. So in other words, it's not that there's an f of x, but that there's a function of an observer of x, and that is what determines what is measured or what is observed. It's dependent on the observer as a kind of participant, as an active participant. Now, if we jump for a second to the way we think of most so-called interactive environments and devices these days, there is some kind of input, and there is some kind of output. An f of x converts something, an input into an output. And we tell ourselves that because we can't predict what the input is going to be, we can't necessarily predict what the output is going to be. But in fact, if you tilt it, you realize it's actually still the same f of x, right? The function has not changed. The transfer function has not in any way changed on the basis of either the participation or the observation, because the way it's converted, if you like, from input to an output has remained exactly the same. What I call interaction is when the participation actually affects not just the output, but where it actually affects the function that calculates the output. So interaction is different from reaction, right? Reaction is where I push something and it moves. Interaction is where I push something and I change what it is that calculates what happens on the basis of my push, if you like, right? So it's not the very conducive light switch that switches on and off a light. It's the slightly more troublesome light switch that you're not really sure whether it's going to switch on and off a light, because there is some other modulation, if you like, of the transfer function. Whether that's time-based or whether that's random or whether that's based on some other input is a different kind of question, which we can come to later. The most interesting type of interaction for me is what I would call a conversation, which is what occurs when both entities are observing one another and both entities are changing the way they respond to any given input. And it's only through this kind of relationship that truly, if you like, innovative vocabularies of interaction can be developed. You've got to have a means of changing that transfer function, that what I was calling the sort of f of x, in order for there to be any kind of conversation, for there to be any kind of development, for there to be any kind of, if you like, real engagement. And so this is what I'm talking about when I talk about interaction. And I don't want to claim that every one of my projects is actually falls under this category, but more that this is the aspiration to which I'd like to get. For those interested to look a little bit further into this, the fellow who's actually espoused this is, not zooming in at the moment, but it's Gordon Pask, It was Gordon Pask in the 50s and 60s and 70s who actually developed something called conversation theory, which is much more rigorous than I've been in my very brief discussion. So next, systems. What do we mean by systems? This is also a very large word and very small word, meaning almost nothing. And what I tend to do is I actually have a sort of set of classifications of what I mean when I'm talking about systems, so that I can start to understand and to evaluate exactly what it is I'm trying to do. On the one hand, there are static systems, and one can think of things like a chair is actually a system, because ultimately for me a system is a description of a set of relationships. That is all a system really is. It's a description, which means that there is somebody making the description. There is a describer, if you like. It's a set. That means that that person who's making the description is actually drawing a boundary around something and saying it consists of all the stuff inside here. And finally, it's relationships. It's not about the individual entities, if you like. It's about the relationships between the entities. And that ultimately, for me, is what a system is. And so that's why I think it's perfectly valid to talk about a chair as a system. It might be a static system. On the other hand, you might have dynamic systems. And on the one hand, we have linear systems. If I can just zoom in here. This is a sort of familiar model for people who are interested in interaction. It's the idea of the input and the processing of the input to the output. It's that f of x thing again. Now, sometimes we convince ourselves that we've designed an interactive dynamic system because there's a person in there feeding back on the basis of the output back into the input. But ultimately, because that process doesn't change, this is simply a reactive system. What's kind of more interesting to me is what I would call closed-loop systems. And on the one hand, we have the self-regulating system. And this is where you do have an input and an output. You have a measurement, and then you have an act on the environment. But the way that input is processed is dependent on a goal that has been set. And the typical example used here is a thermostat. Right? It's not just where it's measuring temperature and then raising or lowering the air conditioning or the heating. It's about actually having a dial on there that can change at which point the heating or air conditioning is switched on. So this is what's often known as a self-regulating system. A learning system is where you actually have a cascading of these comparisons, if you like, cascading of goals. And what you see here is what you might call the thermostat at the bottom. This you could call the thermostat, has a person who's setting the goal, who has a goal to be hot or cold or warm or comfortable, or turn the heat up because the lover's coming over, or turn the air conditioning on because it's going to have a cocktail party, or what have you. What's happening here is that because there is another goal-seeking entity that's setting the goal of the thermostat and learning what is the point at which to set the temperature, that is where the learning actually occurs. And what's interesting to me here is that in order to have a learning system, you have to include the human being in the learning. That's the way I see it. You're not necessarily going to be able to create something that learns itself unless there is an external observation that's able in some way to learn with it. And that's for me quite an important distinction, because I think for there to be any kind of learning process, there's got to be some kind of engagement with something that's already capable of learning. Of course, coming back to the idea of conversation, when you have these two learning entities responding to each other, then that is what conversation is, when you have two entities that are able to learn from each other. And that might be the nirvana, if you like. I don't claim ever to have reached that. So, kicking off with some projects. This one actually goes back to 1999-2000. And it came from my interest as an architect, again, and the experience of space, and an observation that, that of all of the scents, smell is one of the most underutilized in the design of space. And that's kind of for obvious reasons, which is that it's so difficult to control. Where smell has been used in the design of space, it's largely been used for marketing purposes. You've probably heard of the hotel whose lobby throughout the world smells exactly the same because it's got a signature scent. Or you might have heard of pumping the smell of fresh bread or coffee out of the front of a supermarket to attract people in. That's the way smell has been used largely. So what I wanted to do was basically figure out a way to position smell in space. You know, actually literally to have one smell here, one smell here, smell here, to basically treat it like pixels. And as you'll find, I very often do these things in a kind of low-tech way. I'm hoping I could kind of like leap and point at things. What's happening is that there is it's essentially a really slow-moving wind tunnel. And so on the left-hand side, you see the fans that are pushing the air through a series of diffusion gratings until finally smell is injected in these compartments just before the last wall pushes the scent out. And what happens is that because the air is moving in a straight line at about this kind of speed, and it really is laminar airflow, it's air that's moving pretty much dead straight. When you inject smell at a particular point, then it just drifts down the zone inside. Now, what's intriguing, of course, is that as soon as a person interrupts the airflow, they mingle up the smells that have sort of wafted over their body. We did make one slight mistake, which is that we put a lot of bad smells down low and totally forgot that that was the only thing that kids were going to smell. But the point really here was that to show that it is possible to build up these ephemeral zones and boundaries using smell, but also to look at a system where it's impossible for two people to experience the same thing. Because as soon as somebody goes in there and experiences something, they actually alter the condition of the space in a very physical way because they mingle the smells or because they interrupt the airflow or what have you. So this is my first sort of stab, if you like, at doing something to do with software of space that also had this idea of the sort of participation of people within it. A couple of years later, I did a project called Skyair. This actually started in my studio in Japan. I was an artist in residence in 2000 in an institute, and there was a beautiful artist studio that they gave to me, and it was quite large. It was, you know, it was almost from here to the other wall over there. That was just for me. And there was a beautiful spot for my desk over there, sunlight, you know, power cords, network, Ethernet cable and everything. But my mobile phone had no connectivity over there. It was only over here at this end of the room that I could actually have any kind of mobile phone connection. So what I had to do was leave my mobile phone at this side of the room and then sit on the other side of the room. And every time the phone rang, I had to sort of run across, pick it up. And I ended up basically building up these maps of rooms based on their mobile phone connectivity in this building, because it was slightly submerged underground, which is why there was this sort of strange condition. And so what I did was, you know how on the mobile phone you have the signal level bars? I just walked around taking measurements at different moments and actually figuring out what this kind of undulating topography of electromagnetic space is, if you like. And of course, it changed dramatically over time. And so I realized that this kind of, it is a physical phenomenon, but it's one that's intangible to us, was affecting my movements, again, in much the same way that walls and corridors do, because it was sort of encouraging me all the time to go over here and back and forth and all this kind of thing. And I wanted to try and get a handle on what this Hertzian space is, if you like. Hertzian space is the term that's used by industrial design theorist Anthony Dunn to describe the space of our mobile phones, our televisions, our garage door openers, these kinds of things. Not just electromagnetic space, but the space of our sort of information, if you like. So I decided to build basically a very large sensor grid that would consist of 1,000 sensors, if you like, that were in some way responding to the electromagnetic fields of mobile phones. I realized that I would need some kind of visualization of each of those points. And so I started thinking about this sensor being attached to some LEDs in order to light up and to change in response to the electromagnetic condition at that particular point. It occurred to me that the most interesting thing would be not just to measure on the ground, but actually have this thing rise up into the air, to actually carve out, if you like, a sort of chunk of electromagnetic space and visualize it in some way. And so I decided to embed these sensors and the LEDs into balloons, because the balloons could provide it with lift, fill them up with helium, and the balloons also act as a wonderful diffuser of the light, and you'd actually be able to see from quite far away what the electromagnetic condition was. So this was starting to look like a sort of 30-meter diameter cloud. 30 meters is roughly 90 or 100 feet in diameter. Now, going back to the idea that I'm not really that interested in a so-called objective measurement or a sort of objective view of the situation, it occurred to me that what would be most interesting to me, at least, would be to take this cloud and embed it with dozens of mobile phones, because the idea would be that people would be able to observe this cloud measuring the electromagnetic fields. They could call into the cloud to listen to the sort of textures of this electromagnetic fields converted into sound. But the action of calling the cloud would actually alter the electromagnetic fields that they're trying to measure, so that it becomes effectively a kind of performance measurement, if you like, that is brought to life through the interactions of the crowds underneath. Like any good architecture student, I don't know how many architects there are here, but I took on the Gaudi approach of building lots of models upside down, because gravity is symmetrical, because I knew that with a 100-foot diameter cloud, I'd be dealing with more than a ton of wind load. So actually, apart from all the technical issues of building the electronics, just flying something this large was going to be one of the largest problems. And so I did a lot of experiments to figure out how exactly to control this thing. The idea here is basically that I'm going to be sending it up about 100, 150 feet into the air and up and down, and basically trying to sort of swoop and catch the electromagnetic space. I had, after many experiments with different structures and different netting systems, I had the very good fortune to bump into the professor of unsteady aerodynamics at Imperial College. I didn't know there was such a discipline, but he helped me figure out that if I created a sort of carbon fiber rim to the cloud, that it would help it fly much better in the air. Because what I discovered was that if you want to send balloons up into the air and you just want to tether them, then the wind just constantly pushes it down. No matter how, almost, you'd need an incredible amount of buoyancy for the thing to stand straight up. So you actually need to make it, even with all the helium in it, you still need to make it fly like a kite. So these are some experiments here to actually get this thing to fly. So you'll see in my project that I very often start from an idea and then I just try and build it. For me, it's easy to come up with the ideas, but actually to put something into reality is the hard part. So all of these things are done perhaps naively, just sort of trying things out. But the important thing is for me to actually just do whatever I can with the means I have available. So on the left, you see that I actually managed to get up about 60 meters or so, which was the height I wanted to get. And on the right-hand side is my sort of photoshopped version of what the full-size version would eventually be. Keep a look at that building in the lower right-hand corner. That's the Royal Observatory, because in the darkness photos that are coming up, it'll give you some idea of sense of scale. So this is roughly what I was planning to do. Basically make a duvet or a ravioli filled with balloons and electronics and mobile phones, and then fly this thing somehow. I got together with some friends, and we had lots of solder parties building the electronics. And what you see is basically that this board has, it has 6 LEDs, red, green, and blue. It also has infrared LEDs, and it also has an infrared receiver. Now, what this means is that the balloons can coordinate through the infrared. We call this the B2B network, the balloon-to-balloon network. And it's also got a coil. It's just a very simple coil, which is really not that different to the induction loop that you might have seen on these stickers that you put on your mobile phone that flash when a mobile phone call comes in. So it's fairly, I won't say basic technology, but it's nothing that high tech. And then there's a microcontroller, which converts the input and basically goes through a number of different modes in converting it into some kind of visual output. Because the interesting thing about doing something of this scale is that there's no real easy way to calibrate it without flying the whole thing. And flying the whole thing is an incredibly expensive proposition. And so you basically have to plan for many different possibilities of what you're actually going to find when you're up there. So I also had to build a valve to be able to inflate the balloons as quickly as possible. It turns out, because again, I did experiments about this again and again. Turns out that if I take more than 5 hours to inflate the structure, I will have lost 10 to 15% of the buoyancy. So I had to figure out a way to inflate this thing as quickly as possible. And so I came up with this valve that would enable you to just sort of shove a nozzle in, inflate, and move on to the next balloon. So what we're doing is basically taking the electronics with the valve, shoving it into a balloon, and then putting the balloon into a bunch of nets. And here we are setting up on the day. You could get an idea of the sense of scale of this thing. This was the first time that I did something actually quite large scale in public. And it hadn't occurred to me at the time, but now seems quite obvious that, of course, it attracted a lot of people to, who just came along to find out what was going on. This is some video here. I think I have, let me try plugging this in here. So it took about 30, 35 people to inflate it, and a whole day to put it all together. So there's the building on the right-hand side. These are the sounds that you might have heard when you were phoning into the cloud. These are basically the sounds of what are known as spherics and whistlers, which are a natural electromagnetic phenomenon that you can sometimes pick up on your radio during a storm. And this is the kind of thing that you would hear when you phoned into the cloud. Now, what you'll see is that it'll be responding very differently at different occasions. Sometimes flashing, sometimes coordinating, sometimes creating patterns, sometimes just a sort of general rolling of color. What we are doing is sometimes looking just for that, that sort of galloping beat of the mobile phone as it rings. Sometimes we're looking just for a general background electromagnetic fluctuations. Because again, we had no idea what would actually work. What would happen when 1,000 people come and try and call into this thing? How much EMF would we actually be generating? We had to plan for many different possibilities. The other thing we did was we only announced some of the mobile phones at different times. So at one moment, there'd only be one mobile phone number available, which only one person could call. And you'd be able to see that only that portion of the cloud would come alive. So here are some photos that give a slightly better idea than the video of what it actually looked like there. Say that again? That's right, yeah. And so you'll see that there's this green laser across the sky. That's actually the line of Greenwich Mean Time. We had originally planned to do this in every time zone and sort of do a sort of electromagnetic disk around the planet, sort of capturing it. Of course, we had to do things like get air traffic control. You can see there's an airplane flying nearby. We're not that far from an airport. But it was kind of interesting to me to figure out how to explain this project in the context of something like a request for airspace. And this, again, has become a theme quite often in my later work, is how to interface the kinds of things I want to do with very strict bureaucracies, the local governments getting permission for these kinds of things. So I'm going to skip Haunt, but Haunt was basically a project that was an attempt to replicate the environmental conditions of haunted spaces, taking the sounds, the infrasound, the electromagnetic fields, the humidity, the temperature level, and then running 100 people through the experiment and only switching on some of the equipment at some of the time, and then seeing who actually experienced anomalistic sensations. It was marginally successful. The reason I don't bother showing it right now is because actually there's nothing to show. It's an experience more than the documentary of the videos of people saying what they experienced. So I'm going to skip ahead to Open Burble. One of the frustrating things about Skyair was that I had not intended to do a spectacle. I had intended to do this thing that was actually not about the visual, it was not primarily about the visual effect, and yet it became that. And it also seemed to frustrate a lot of people, a lot of the members of the public who had turned up to experience this thing, that they couldn't fly it themselves. Which I just couldn't allow them to do at that stage because it was a pretty dangerous thing, as I said, like a 1 ton of wind load. And so I was, of course, asked to do Skyair again, but I'm always reluctant to repeat projects. And so I started thinking, well, what would I do? How would I change it? How would I make it what I wanted it to be? How would I actually get people directly involved in the participating in the actual construction of the experience? And it occurred to me that, okay, I got 1 ton of wind load, but if I had 200 people holding it, then they would only need to carry 5 kilograms each, which is really easy, actually. Skyair took 9 people holding it and a whole bunch of pulleys and things like that. But if I could redesign it so that 200 people could hold it, then I could reasonably safely say that they could take control of it. So that was the first observation. The second was that I could actually take this kind of modular system of the balloons and the carbon fiber and the nets and the ropes and things, and actually turn it into more of a kind of Lego kit, where if I was to provide it to members of the public, they could start to snap it together in whatever kind of configuration they wanted. They could start to build these kind of molecules. They could then come together and actually design a much larger structure, which would be entirely of their design and creation. So they'd be involved in designing it, albeit not in a, it's not a super involved design question. It's more about making patterns. But it is a process of figuring out for yourself what is the right pattern, if you like. It would enable people to go through the same kind of processes that so-called professional designers go through, of self-critique, of discussion with each other, negotiation with your neighbors. How do you get this thing to fit to yours? Is this right? Does this look good? What does good mean in this context? And so I decided basically to create this modular system in such a way that you could snap them together in any configuration, and that the patterns that were generated through the structure would be directly influenced by the way it had been snapped together. So in other words, I had no way to predict what the patterns would be like of light as it flows through the structure, but it would be based on how people had designed the structure in the first place. And so what I actually planned to do was, if you think of this as the structure, then, and if you think of each of those as each of those circles as slightly higher than a human being, that along the bottom edge would be a very long handlebar where 200 people could hold onto it. The handlebar would be embedded with basically the same accelerometer sensors that are in the Nintendo Wii, and that as you move and shake and trigger and wave this handlebar, it would sort of inject color into the thing that I'm now calling the burble, and that the way those colors flowed would be based explicitly on how it had been designed and constructed in the first place. So here's the carbon fiber module with the balloons being assembled. This was done first in Singapore in 2006, and then inflating it. And here's some video. So. So what was interesting to me here was that ordinary members of the public come together, they participate to build something at the scale of a 15-story building. It's probably one of the only times they have the opportunity to do something at the scale of a city, where they've actually somehow changed something. It might just be for a short time, but they've actually done something huge, and they can actually point at the bit that they created or the bit that they decided on. Whoops, slightly off-center video there. Anyway, these are some photographs of the same. Now, implicit in all of this is that I have to trust that the people who are holding this thing are not going to let go. And this is a kind of important thing for me, that in a sense, members of the public are trusting me to do something for their space, and I'm trusting them to just take on this thing that's been provided for them and not damage it or not chuck it away. And one of the most gratifying moments after doing this in Singapore was reading somebody's blog where she said, "That's my baby up there." And you know, it wasn't about it being my project, it was about it being her project, because that was the whole point, for it to become somebody else, for other people to take ownership of this, to do something at the scale of their city. Reconfigurable House actually started as a critique of the smart home. You know, this idea of the closed, this sort of wonderful interactive home that we're being promised. I'd actually done a manual for low-tech sensors and actuators. This is for our artists and architects, how to hack really inexpensive devices and toys and cats and things for their very inexpensive sensors, and then building things like, you know, bricks, touch-sensitive bricks that are super cheap. And so with my friend Adam Somlai Fisher, who I did the pamphlet, we decided actually to build a kind of prototype house out of all of these thousands of sensors and actuators that we were able to build very inexpensively. Now, the difficulty or the problem for me with the usual notion of the smart home is that it's impossible to do DIY on it. And very often they're sort of planned as kind of closed boxes that the inhabitants basically just choose their desktop pattern. And that's effectively their only participation in the system. With the Reconfigurable House, I wanted to show that it's possible to design a house full of sensors and full of actuators where there has been no program specified at all, but where the occupants start to specify how the inputs connect to the outputs. What are the actual interaction algorithms that are used in the space? And so we basically made this prototype house filled with the responsive cats, the squirrels that bark, the penguins that squeal, the monkey that says "I love you" when you pass by it. And it's the point of the very cheap sensor technology is that they're actually they're quite sophisticated. So I don't know if you've seen this cat. I should have shown some video, but it's the one where when you clap, it goes meow, meow, meow. Have you seen this? It's a sort of like, you know, it's a sound to, it's almost like an analog to digital converter, right? Because its eyes light up as well. So you can use the cat as this kind of universal bus device, if you like, to plug in. When you've got the monkey that says "I love you," if you connect the monkey to a cat, because the monkey makes a sound, the sound triggers the cat's eyes blink, you connect its eyes to the penguins, then when you walk past the monkey triggering the cat, it actually gets the penguins to start squealing. So you could, if you wire it in that way, you could actually make a sort of very primitive burglar alarm, if you like. So here's some video. what we basically had was a touch screen where people could connect anything to anything else. So if they wanted to connect, let's say, an MP3 player to every device in the house, they could actually get the whole thing throbbing to their music. And so it could be their kind of disco mode. This is the 3D interface where you could start to click and drag things. And of course, every single thing is either an input or an output, depending on where it's been placed within the system. That's the cats lighting up there in the bricks. There are the monkeys. The point here was to show that A, it's possible for non-experts to build the hardware, because it's not super simple, but it's not that difficult to rip apart a cat and take out its electronics. But also all of the code was built using open source software like processing, and so all of that code was open sourced. The actual configuration of the house as well was dependent on the occupants. So it's basically this idea of what I call the granularity of participation. The people who want to be able to code are able to recode this system. The people who want to just add in new bits of hardware, new gadgets they found, are able to do that. The people who just basically want to connect a cat to a monkey, they can do that too. There are these sort of different resolutions of participation, which I think is important in any kind of participatory system, is to figure out many different entry points for people to be able to be involved. Because if you're only open sourcing the software, then you're only going to be able to have the participation of coders who know how to work with open source software, et cetera, et cetera. So this idea of granularity of participation will come up again. These are a couple of other versions of the project. Let's see. Okay. Primal Source actually came about because I was asked to do a spectacle for potentially 50,000 people at one time. And I was trying to figure out what would be the best way to involve people all at the same time. And it occurred to me that their voice was actually, it's one of the most intimate things we can do, right? We take air into ourselves and then we expel it in this kind of expressive way. And so what I planned to do was basically build a huge cloud, like an aurora borealis above the beach in Santa Monica, that would somehow come to life through people's actual, the enunciation of their voice, to figure out a way to get people basically to be primal in public, to scream and shout and really to express themselves in a way that they're not necessarily free to do otherwise. And so what you see here is that every single one of those particles that's flying around is one person's voice. It's based on the frequency, it's based on the amplitude, and it's based on the sibilance of the screen. And the really important aspect of this, to get people to feel, to know that they were doing something, was to have that response from the sound input to the visual output to be as immediate as possible. Because actually you draw in the causality. If something happens within a particular frame of time, then you feel as though you've caused it. In fact, you did cause it, but we just here had to make absolutely sure that people knew that that had some effect. What was kind of interesting to me was that, again, looking at a blog post a couple of weeks later, somebody wrote, having not been there, "Why are all these people screaming? Don't they know that art is meant to be experienced in quiet contemplation?" Oh, that is that's basically a kind of mist screen. It's a fog screen. The way that is done is actually quite low tech, which is that we have some pumps, which you see here, and they suck in the water and then they send it in a straight line out to that nozzle. And the nozzle is basically 2 aluminum discs that are separated by a 1/16 of an inch. And the water just hits it and just explodes 120 feet by roughly 50 feet high with a very fine mist. And so we did a bit of experimentation of whether a 1/16 of an inch or an 1/8 of an inch worked better. And there's a trade-off. When you have a 1/16 of an inch, you have a much, much finer mist, but it's also much more difficult to control where it's actually going to go. Patch Bay is something I spoke about yesterday, so I'm not going to dwell on it too much right now. But essentially, Patch Bay is take Reconfigurable House, and here we talk about Reconfigurable Planet. The idea here is essentially it's a web app, and it's now used by thousands of people around the world. It's a means of sharing in real time environment and sensor data. And so the idea is that if you plug anything into this, whether it's a biosensor or a building management system or an Arduino or some other microcontroller, a pollution sensor or what have you, you're able to share this data in real time with other people. One of the most popular uses is for things like electricity feeds. We can see here, let's see what we get up. So here's an example of a building that seems to be tracking solar measurements. And the idea here really is to make something that's as easy as possible to build networked objects and environments. If you know Nike Plus, which was this, it's a running shoe with a sensor in it. There was a collaboration between Nike and Apple. What they were able to do was build up a web community around a physical product. And it was actually a reasonably straightforward proposition for 2 very large companies because they have large engineering teams. They have, they've got the infrastructure experience and the technology experience. But for small to medium scale product designers and manufacturers and developers who are just now waking up to the potential for networking their environments and their objects, electricity meters and sensors and things, it's a much more difficult proposition to think about how to build a scalable, highly available server infrastructure for sharing all this data. Effectively, what we've done is build a kind of YouTube for environments to share their data in real time. And so that's why I call it the kind of Reconfigurable Planet. It basically means that people are able to create a web page around their sensor feeds, but they can also make available all of this data in real time to other people. They also have graphs that they can embed in their websites, et cetera, et cetera. This is actually the project that I'm concentrating on most at the moment because it's actually spun off into a separate company called Connected Environments. But since I spoke about it quite a lot yesterday, I'm going to leave that aside for the moment. I'm going to show you instead something that I built using Patch Bay, because this is an example of the kind of project that becomes much easier to do once the network traffic between devices is taken care of. Natural Fuse is basically it's a local scale carbon dioxide offsetting system, if you like. The idea basically is that we made this, it's a house plant with a power socket on it. And the amount of power that's available to that socket is limited by the capacity for the plants to offset its carbon footprint. That's why it's called Natural Fuse. The idea is that if you want to remain carbon neutral, then you could have this device that would ensure that you don't use more electricity than you can safely offset with the plants. Now, the difficulty is that one set of plants will barely offset even a low wattage light bulb. And so what we do is we network them together so that when people take them home, as you see, we had them in New York, in Spain, and the UK, people take them home, plug them into the network, and what happens is that as long as there are 5 other units out there in the community that are not currently being used, in other words, being switched on for an appliance, you can borrow their carbon offsetting capacity and apply it to your own appliance. Because a low wattage light bulb of around sort of 5 or 6 watts can be offset by 6 units. So what happens is that every time you want to switch on, then it just wakes up, checks the network, finds out how many are out there, and on that basis decides what to do with the appliance, whether to power it up or not. However, rather than just having an on-off switch, what we do is we give it what we call the sort of, it's an off, or you can be selfless, or you can be selfish. And the idea is that if you decide to be selfless, then it'll wake up, and if there's enough carbon sinking capacity out in the network, it'll give you as much power as you need. If there's not enough carbon capacity in the network, then it might switch your electricity off after 15 seconds or 20 seconds, maybe longer if you're using a radio because it's much lower power. But the idea is that it will prevent you from harming the community's carbon footprint as a whole. Sometimes, however, you do need to be selfish. You might have heard an intruder in your apartment or what have you, and you really need to get that light on. So you switch it on selfish. And what happens is that it'll give you as much power as you want, but if you harm the carbon offset capacity of the community, if it goes positive, in other words, then it will kill somebody else's plant. And it does this by injecting vinegar into the soil. Now, in practice, what we actually do is we give each unit 3 lives. You know, the idea is that you do have an opportunity when a kill signal is sent to a plant, both participants get an email, and it says, you know, by the way, you know, unit 15 owned by this person just killed one of the lives of your unit. And they now have this opportunity to email each other and sort of explain what happened or threaten or what have you. The point really is to build up some means of communication between people on the basis of understanding how their consumption of resources affects other people. It's not about telling people you must save energy. It's more about saying you can all save energy. If you need to, you can use more, but it will have these impacts, and just be aware that these are the repercussions that it may have. Finally, I'm just going to wrap up with a project that we just started 6 months ago, and this is going to take about 3 years to complete. It's called Another Life. It's right at the beginning of the project, so it's still at the kind of conceptual stage, but I thought it'd be worth leaving you with a sort of departure point, if you like. The idea here is that it's in a small town in North England, and the whole city center is being turned into a park. And the park is filled with all sorts of things, fountains, a pond that can be filled or emptied. It's got LED lighting in the floor. It's got colored lights on the buildings. It's got a projector. It's got all sorts of sensors, camera tracking, et cetera, et cetera, et cetera. It's basically jam-packed with technology. Loads of technology and no idea what to do with it. And so what I've basically decided to do is turn this into a kind of reconfigurable house type environment for the city. And so thinking about this again in terms of granularity of participation, it's the idea that we're going to open source all of the software, we're going to make it possible to plug in different sensors or actuators if necessary, but also people will be able to change the way the park responds to them perhaps on a weekly basis, perhaps not immediately, but you'll be able to sort of program the park to do things. And so we're thinking of this kind of as this interaction engine, where on the one hand we have a load of inputs, things like visitor position, sensor values, the lunar cycle, what day it is. There's a control table, there's weather, et cetera, et cetera. On the output side, we have things like pools and fountains, and we have what's called the Bradford Blast, which is this huge jet of water. There's the ambient color lighting in the environment, in the floor, et cetera, et cetera. And what you can do is you can basically program certain things to connect to other things. So, for example, if you take visitor position and you know it's nighttime and there's some kind of community interaction which is affecting the ambient color lighting and the projector, then you can get something a little bit like Primal Source. So you'll be able to create, Primal Source being that sort of fog screen projection. So what we're doing is we're taking positions of visitors and turning it into an interactive projection on the mist, but only at night. On the other hand, you might take the control table where you can plug in an MP3 player and you plug that into the jets, that is the sort of perimeter fountains, and you'll be able to create this kind of MP3 response water going up and down. You might, on the other hand, take the position of the visitor. You know what time of day it is. You know the position of the sun, and you can direct people to a particular point using the LEDs in the floor. When you know the position of people and you can create water and you know the position of the sun, then what you can do is you can create a rainbow. Because a rainbow is created at an angle of incidence of 42 degrees, the sun behind you, the mist in front of you, and the position of the visitor. So what you can do is you can actually create a rainbow that's only visible to a few people. And so really the key to this project is to almost like foster urban myths. People think they've seen things and claim to other people that they've seen a rainbow or a ghost shadow or what have you. But not everyone has ever had the same experience. And then finally, I'd like to leave it there because that is the project I'm involved in next. So thank you very much for your attention. And please do let me know if you have any questions. Thanks.
Thanks very much, Usman. So we're going to take questions, and if you don't have any questions and you have to go to the loo, please come back at 11 o'clock, where we'll be talking about data and information in the palm of our hands with the also pretty incredible Carla Diana, who'll be showing some of her work, and both Usman and Carla will be giving positions on the topic, and we'll be having a nice discussion. So with that, thank you once again, Usman, for a really incredible presentation of your work, and let's take some questions.
Any questions?
Please use the mic.
So I'm curious in the piece, I don't remember what it was called, but with all the balloons and the community, what exactly, this is technically, but what was the connection between the different balloons? I mean, how exactly was that all happening?
That's actually an interesting question because, of course, none of these balloons actually have an address. No balloon knows where it is within the system, especially since they could be connected together anywhere. And so what we did was that carbon fiber structure, the balloons, unlike Skyair, where the balloon was in a net, in this case, the balloon was attached to a rubber band, actually. It was not actually a rubber band. It was taken from, if anyone's into fishing, there's this elastic cord that's used for catching sharks. Apparently wears them out, and it's an amazing shock absorber. So the balloons were attached to this rubber band attached to the carbon fiber. What that ensured was that all the balloons were always pointing upwards. So when you have an infrared signal, you could basically send a pulse upwards and know that it's going to reach 2 balloons above it. But you're not able necessarily to send information beyond the idea of a pulse because the balloons above don't know where that pulse has come from. So what we'd do is we'd accumulate the number of pulses received in any 64th of a second. And on that basis, we would either push round the color wheel or sometimes pump up the color and then go back down when the pulses had subsided. But essentially what it was doing was integrating in much the same way that the nerve cells integrate spikes rather than trying to send information. And it was all based on the infrared communication.
What was the initial thing that triggered it?
The handlebar has these accelerometers in it, and it would basically send up infrared spikes on the basis of how much it was being shaped.
Austin Henderson, I love it. I'm intrigued by your notion of system at the beginning, collection of pieces, and amongst this, in addition to all the wonderful technology, are all the wonderful people who, in the end, are making it happen. When you're trying to look at the system, it seems to me some of the things that the system is doing is giving off stuff, but some of the thing is that others can sort of look at it and see it.
Yeah.
Like Pachube. How do you see the parts of the system that are in the humans?
That's a really good question. I think it kind of comes down to, actually, how do 2 people know that they're talking about the same thing?
Only by interacting.
Yeah, exactly, through interaction. And there is some idea of causality. You want to see that there is some connection, that there is some effect. But you also don't want there to be an effect that is constantly repeatable. In other words, if the same thing happens exactly if exactly the same thing happens, then you get bored, or you know that it's a dumb system. And so it's always trying to play with that idea that the participation in some way is altering the way it's responding to you. Now, the project I didn't talk about very much, Haunt, was a kind of interesting one for me because, as I said, what I did was I basically replayed various environmental phenomena and then took 100 people through it. A quarter of them had electromagnetic fields, a quarter of them had infrasound, a quarter of them had both, and a quarter of them had neither. But in all categories, there were people who perceived anomalous sensations. There were people who saw things, heard things, felt a presence. And so what was really interesting to me, and by the way, of course I didn't say this is about a Haunt experiment. For ethical reasons, I do have to say that it's got something to do with anomalistic sensations. But the point was that somehow people infer in a collection of phenomena things that they want to infer. And so that's a kind of interesting tool to play with, I think, when you're working with interactive systems.
So how did you get out of them what they were inferring? I mean, that would be a piece of the state of the system.
That's right.
By talking to them afterwards?
Or
was there a way of engaging it at the moment?
They actually did, they built up a map with a time of when they experienced something and where they experienced it in the space.
While they were
going around. And at the same time, there was a camera that was tracking their movements. They actually had to stay in the space for an hour individually for various reasons. And so they actually had time to actually experience it and contemplate and think about it and that kind of thing.
Thank you. My time's up.
Thank you very much.
Barnalani from UC Irvine. As a software engineer, I'm a bit overwhelmed by the beauty of things, the things that you've created. But again, as a software engineer, I'm really very interested to find out how you coordinated and supported the collaboration among such a large number of people who come together for just this one project and create that sense of trust that they're going to be safe when your creation comes into being, and your trust in them that they're going to do the right thing and not let go. So how did that happen?
That's quite an interesting question. I'm actually going to talk a little bit more about that in the panel next. I'm going to talk about what I call the paradoxes of collaboration. But one of the things that I've found really useful is that it's helpful to only give people 3 instructions. And this is, I don't know why this works, but there's something about not telling people, look, you're going to do this wonderful, massive, huge thing, but rather, why don't you try this, because then you'll get this thing. And by the way, if that person also does that, then it's going to create that. And you don't need to tell them that when everybody does it, it turns into a massive thing, because that is never sufficient incentive for the participation. So I've always somehow structured and I think this is where the design process really comes in, is figuring out how do you actually structure that participation? How do you actually figure out what it is that'll explain the project sufficiently that people want to be part of it, but not over-explain it in such a way that people feel it's already a fait accompli and what they do makes no difference.
Yeah, thank you.
Cindy Lu, and I have a question. Before you start the projects, how did you decide the user's experience or the participants' experience? Did you envision it by yourself, say, here's the project, here's what I want them to do? Then after the event, you look at the blocks and to evaluate what you envisioned compared to what their real experience is.
So that's an unusual question for me, not really coming from a user experience background, but understanding what it is you'd like to get from me. And I'm almost embarrassed to say this, but very often a project actually starts from a dream, and I wake up and I just want to try something.
Okay.
And I do. For example, the Burble didn't actually start with this idea of building a Burble. It was actually, I think I thought about Jack and the Beanstalk, and figuring out how does one grow a big, how could somebody plant something in their garden that grows into that? And the first thing I always do is, I might do some sketches, but actually the first thing I do is actually just build something. And as soon as you start making something, then somebody else can critique it. Somebody else comes into the conversation. Once you've got something physical and full scale in front of you, then that actually offers the opportunity for other people to come and be part of it in some way. So I don't necessarily try and think that much the end goal of what the user experience is.
Okay.
But I do confess as well that I think there is this aspect, which is a very personal psychological one perhaps, which is that I like to do very big things like these spectacles so that I am not, in a sense, I can fade into the background. And you know, I haven't really analyzed myself enough to understand this, but it's more like sort of saying, well, let other people just do stuff without necessarily sort of trying to define whether there's pleasure or whether there's any positive amelioration of condition or anything like that. I certainly don't do the kinds of analysis that perhaps would make this more useful to understand what people get out of it, apart from something like Haunt.
Okay, very interesting. Thank you.
Thanks.
Me again.
Ah.
Could I provoke you to say a little bit more about interacting with bureaucracies?
Sure.
Go.
Anything in particular?
Yeah, I mean, tell me about talking to the ATC, the air traffic control people, or any, well, a more abstract question. What's your view of those who believe the world is regular? And here you are being very particular in a way that isn't in their regular. Now what?
Well, so the fact of the matter is that again, you know, these are all systems, and you just kind of have to learn. You have to learn what it is.
But you're going outside that system, or are you?
Okay, so there's two things here. One is that actually constraints are the most helpful thing when you're designing, I think. And I actually find it really helpful that there are sort of things that I have to do, practically speaking.
Lines you have to walk.
Lines I have to walk, you know, the fact that I've got to get that application in a minimum of 31 days before flight, et cetera, you know, those kinds of constraints. But also that I have to figure out how it is that I can explain this. You know, how do you describe something in language that another person will understand within their very explicit frame of reference?
But could I conclude then from that the way you deal with the bureaucracy is not try to persuade it to be other than it is, but try to figure out how you, through explanation, can be the way they want you to be? Yes, I'm an airplane. Or
kind of, yeah.
I mean,
yeah, for example, with Skyair, I had to basically, I discovered that what you call it is a tethered balloon structure or something like that.
Which is something that's already on their radar.
Yeah, so somehow there's always a category that you can fall into.
Yeah.
You just have to figure out what it is, and what it is, when you fall into that category, that it doesn't prevent you from doing other things that you need to be able to do. And if it does, then you've got to figure out other ways around that. But it's actually not that dissimilar from, for example, when I launched Patch Bay a couple of years ago, I've now had to learn the business of enterprise or the system of enterprise and business, and I've had to figure out how to explain that in a slightly different context. And so it's constantly having to hack, I think. I mean, that's really all it is. It's like hacking. It's hacking different types of systems, whether they're social systems or software systems or hardware systems. It's about sort of opening up and figuring out what's on the inside.
Do you find that some bureaucracies are easier to hack than others?
Japanese is really difficult.
And what makes it difficult?
The fact that I don't know enough language,
Japanese,
right, exactly, to understand what categories I can express myself as, if you see what I mean. And so that is a fundamental difficulty.
Yep. Thank you.
Thanks very much.
David Hendry of the University of Washington. I'm very intrigued by the natural fuse because it seems to control proximate behaviors and allows you to think about the global impact of proximate behaviors. However, I don't think there are so many people that want to buy into the plant.
Who want to what?
Who want to buy a plant and set up that kind of equipment. Could you imagine how such a structure, such an idea could be simplified in some way that more people would be interested in exploring something like that?
Well, I think you'd be surprised how many people do want a plant, especially one that is able to maintain itself. Because actually that is the incentive, that here's a plant that will water itself, here's a plant that you can actually look at when you're far away, and that will just grow and et cetera, et cetera. I think that in a sense, the plant is something that is really important to the project because it is non-threatening as a thing to take into your home, but at the same time you do develop an affection for it. And there was a point at which we wondered whether, imagine that there was a rabbit or something that we threatened to execute. That would be too much of a leap for people to be prepared to buy into. They're more prepared to buy into the idea of getting a plant, which, okay, if it dies, it doesn't matter too much. On the other hand, after they've had it for a couple of weeks, they do actually feel that loss. And so it's this kind of interesting, I don't know what the word would be, but this kind of almost like a boundary item, which actually does satisfy the requirements of insinuating itself into someone's home, but also then developing a much closer relationship. So I don't necessarily have a clear idea of what an alternative to a plant might be. Any other questions? If you have any other questions, feel free to come up afterwards. I'm just going to slowly pack up. Thank you very much.
So, well, we're already giving a warm Kai. Thank you very much to Usman Haque. Thank you.